Hey all, we've got a lot of exciting news for you. SIGGRAPH 2019 may have wrapped up, but there's still a lot to take away from the many wonderful presenters who joined us over the course of the event. Our Unreal Engine user group kicked things off with a lineup of special guests discussing their trailblazing real-time projects, topped off by a fireside chat with director, producer, actor, and writer Jon Favreau. The theater presentations, featuring more great talks from industry luminaries, together with demos of the latest Unreal and Twinmotion features and workflows, will be available to view online soon, but you can dive into our in-depth tech talks in the meantime. Animator and tech artist Gwyn Frey, creator of narrative-driven puzzle game Kine, shared how she near single-handedly developed the game with virtually no coding experience. In our discussion, she talks about the challenges of designing a game for the first time, details of some of the skills she picked up along the way, elaborates on how she leaned on narrative elements when creating puzzles, and talks about how she created the game's sketch-inspired comic art style. Check out the full interview to hear her lessons learned, favorite UE4 tools, and advice to aspiring solo developers. Perhaps best known for its Darksiders series, Gunfire Games' Remnant from the Ashes incorporates fantasy elements into its post-apocalyptic world to deliver a refreshing take on a third-person co-op shooter. To learn more about how a roughly 30-person team managed to nail their unique vision, we spoke with Gunfire, who shared more about the process behind balancing hero archetypes and creating a randomly generated world that's equal parts dangerous and original. It's time to reveal the Twinmotion Community Challenge. We've seen our community creating great images and videos. Now, share your art with the world and have a chance to win some great prizes from Epic. For this first challenge, the Best Sunset, we want to see the most stunning sunset-related image you can create with Twinmotion. Get more details on how you can enter for the $500 prize below. And now it's time for our weekly Karma earners. Many thanks to Clockwork Ocean, Sixer, Don Busso, Spinder MK, Orpheus L, Kevin Ottawa, Jez Central, Christoph Morva, Shadow River, and Evil Cleric. These fine folks have supported devs over on AnswerHub. Head over and answer questions, and you too could see your name up here. And on to our weekly spotlights. This beauty here is Ghost Runner, an action FPP game set in a grim world blending cyberpunk and post-apocalyptic themes. High mobility, the main character, one hit, one kill, and bullet time mechanics are the bases of the gameplay, which focus on fast-paced, high-adrenaline combat. Next up, we have Dream Scraper. 3 veteran game developers who have gone rogue created this surreal Binding of Isaac-style hack-and-slash where players battle a nightmarish depression that lives in a young woman's subconscious. And last but not least for this week's spotlights, we have Regina Esteva, who created this gorgeous moody scene titled Old Rusty's Bar. It's based off a concept piece by Juhani Jokinen. Wonderful work, Regina. We can't wait to see more on your ArtStation from this. Thanks for joining us for our news and community spotlight.
Got no audio. I can't hear anything. I can't hear anything.
We're going back up right now.
Okay. All right, I believe we're back. Back live, as always. There are things that happen when we do this live. Let's see if we can get
a little bit of chaos, if you will.
A little bit of chaos
Come on.
for the Chaos Fundamentals stream. I guess fundamentals of live streaming is that things can go wrong.
For sure.
All right, so to start off with this, let's see if we can get Jack back up. Is he there?
Yeah, he needs to reconnect.
Jack is
All right,
reconnecting.
he's just reconnecting. So to start off with this, Chaos, our new destruction and physics system in UE4. We're releasing it in beta, coming out now with 4.23.
Right. Yeah, I think we can point people to the forum posts if they haven't seen it already, where they can download it and the instructions on how to get it up and running. As you can't use this with the preview version off of the launcher, you're going to have to build this from source. So Victor has a forum post up, has some steps that will outline how to get it up and running, the plugins that you need to enable so that you can start working with it. Again, this will also be covered on our documentation pages, which I'm currently writing right now. So I'm working with Jack to bring the documentation up to speed so that we have it ready to go with 4.23 as well.
Yep. And all you got to do is follow those steps, and then everything we talk about here today should
Should be able
get
to start
you.
playing with it right now.
Yeah. Cool. And we got Jack back on the line. All right.
Hi, yeah. It wouldn't be a good debut into live streams if it didn't go completely wrong.
Of course, of
I'm
course.
back. Hi, how you doing?
Oh, we're all good.
Thanks for coming on, Jack. We appreciate it.
Yeah,
No
especially
problem
since
at all.
you have prepared a lot of really amazing content that you're about to show us.
Yeah. So obviously, we're introducing Chaos properly in 4.23. Essentially, at this stage, we're really looking at a destruction system. There's quite a lot of new paradigms that come with that. And so what we're going to try and do today is we're going to just roll right back to super simple and work our way up. And hopefully what that's going to do is going to give people a pretty good grounding so that they can then sort of comfortably go off and start doing their own experimentation with the system. So whenever you're ready, we can start looking at
I
that.
think we're ready. Let's go.
Sure.
Alrighty, so so first thing to consider when we're working with Chaos assets is the geometry collection. That's a pretty good place to start. So let's start with the simplest of the simple, and we'll just bring a cube out here. So at the moment, it's a static mesh, and even though there's just one of it, we can still turn that into a geometry collection. And to do that, what we're going to do is we're going to move over here into the Fracture Editor tab, and we're just simply going to generate that asset. Just put it in this folder for now, like so. And you can see we've already swapped out the type, and this is our rest collection here. This is what we're pointing to. And you can see here in this outliner, we've just got a cube, obviously. That's what we would expect. And if I bring up draw diagram here, now we can see what the current settings are going to apply to that if I am to fracture it. So here we've got quite a lot of cells. Let's reduce that a little bit and hit fracture. And you can see immediately the hierarchy has updated to reflect that. Up here we have our hierarchy. At the moment we're showing all. And basically what that's saying is I want to see every leaf node. And the leaf nodes are effectively where every piece of geometry terminates, the smallest it gets to. And those can all inhabit different levels. So this allows us just to see them all in one place. But if we work down the hierarchy, we have our root. This is the original cube that we started with. And then we can step down to level 1. We've got some shortcuts to be able to do this. So if I do Shift W, I move up. And if I do Shift S, I move down, like so. And I can also expand these out as well. And again, we have a slider over here, but we can also use Shift E to do that and Shift Q to close that back in. So we can really see what's going on there. So there we have a very simple hierarchy. Let's do something pretty similar. And this time, let's work with a few objects, because there's a couple of useful things to know doing that. So we've got 3 cubes here. We're going to turn that into a geometry collection as well. And it's worth taking note of the fact that if you take the first selected and then add to that selection, when we convert this to a geometry collection, we're going to pick up that pivot point. And that's really useful if you're creating buildings and so on. You want to make sure you know where the footprint is, and that allows you to target that. If these are all nested into a blueprint, for example, we'll pick up the root pivot sort of naturally from that. So let's convert that, and we'll call this cube stack geometry collection, or whatever we like, really. And you can see here that we've, again, created this hierarchy, but you'll note that rather than just having this single stack, we automatically have 3 new bones for the 3 initial cubes that we built this from. So if I deselect that for the moment, we can walk the hierarchy. So there we are at level 1, and then up to level 0, where that is, right? So then we can obviously fracture that, and we can walk down the stack and start to see what that does. So that's a very simple approach to a geometry collection. Let's do it with something.
Do you want to share the keybinds you're using to go back and forth in the hierarchy?
He said earlier, but yeah, shift.
Yeah,
shift
So basically, just as a reminder, it's Shift Q and E to spread apart and to close down, and then Shift W and Shift S will help you just walk back and forth. So let's take a blueprint module, something simple, I think. Columns are pretty good. So here we have something which is, more like a proper asset. We've got UVs and textures applied to that. And this is built from 2 static meshes. We're going to convert that right now to a geometry collection as well. And we'll put that in the same folder. We'll just call this something simple, GC column. There we go. Bring that up to that. Right, now, I'm going to save this straight off the bat. We're looking at this REST collection now, and you can see one of the things that's happened. We had materials on the outside. Okay, I'm just going to deselect that. And here's another useful shortcut. If you do Shift B, you can actually access through the icon here. You can turn off those bone colors so you can see what's going on. And automatically, of course, we're going to have a hierarchy there. So we can see the 2 pieces that this started from. But you'll note what this has done when we've created the geometry collection is it's looked for the materials that we're displaying on the outside of this. In this case, we have a block of concrete and a block of stonework, say, and it's duplicated those material IDs underneath them. And this is where we're going to be able to put sort of tiled materials once we fracture. Of course, we're going to be starting to generate new geometry there. So we're going to want to display something. So even though these are sharing textures, because I intend them to show a different material, I apply a different material instance. If we were to build a full building of that, and I'm going to just jump over here to the geometry collections content example, which we'll be releasing, you'll be able to see that we've got a lot of shared textures on here, but you can see that the material definition is different. So we've got glass on glass, metal on metal, just so that we know what to put inside. And this example kind of shows that when we break that open, we can see how the concrete and the stonework have been separated. It's worth noting as well, when we're working on creating geometry collections, it's a really good idea to be using watertight meshes. You've got to use watertight meshes for the fracturing. Try and keep things non-intersecting. We actually can handle a bit of intersection, but it's generally good practice to avoid that. And also, yeah, we'd recommend that you sort of obey the gridding system as well, as that's going to make building this stuff up a lot easier. So let's just jump back over to here, and let's do a bit of fracturing on this. We'll do something pretty straightforward. Fracturing is kind of one of those things that's sort of best experimented with. You've got quite a few tools here at your disposal, and again, we have a content example kind of walking through the different options that are currently available. So here we can see the many pieces that we've generated. And at the moment, if we were to simulate this object, we're going to see that this is going to, well, actually, let's just do it. See what we get. I'm just going to turn the bone colors off there a second. This is going to be dynamic by default. It's going to have a collision type, which is also default, which is, if I just close this down, this is box. Effectively, what we're doing with box is we're going to be wrapping a cuboid around each of these rigid bodies. And we can see here, this is also particle to implicit. The implicit surface is the box that we're going to check against. And the particles are basically a sort of a spread of the vertices, which we're going to check against those boxes. Now, Box is a very cheap approach to doing this, but what it does mean is because these cuboids overlap, there is what we term as a bit of push out that happens. Let's go and actually have a look at an example of that through here. So you can see this is the kind of thing it's doing. If we use sphere, we're going to insert spheres inside of each rigid body, so we get less intersection between those collisions, but also there are other sort of downsides to that. So here we have Box and sphere next to each other. And you can see how immediately with these default settings, those boxes just really pushed each other apart. The spheres didn't so much, they kind of sink into each other a little bit. We can actually modify the size of those boxes through what is called a collision reduction percentage. And here we have the same thing happening twice, but in the right-hand side, we're gonna see that reduced, like so. And you can see they're not fighting with each other nearly as much. So that's kind of the default collision behavior.
And that's set on the geometry collection, right? In the
That's
settings.
correct, yeah. Right, exactly. So we have all kinds of fun stuff here to try. The other thing I should note is that one of the main things you're always focusing on is trying to keep things really performant. And so there's this setting down here called maximum collision particles. And what that's basically saying is it's saying for any one entity inside of this geometry collection, whether it's a cluster or a single body, you can have a maximum of 60 particles to check collisions against. And in some cases, when, for example, if I had a cluster which contains, 500 rigid bodies, that's less than one particle per one of those. So at that point, we want to start dialing up the number until we arrive at something that's visually good. So let's just start super simple, and we're going to see what we get. I'm not expecting that this first result is going to be too amazing, but not too bad. Immediately, we see the breakup of the base from the column, right? And then that thing starts stomping on it. And the problem there is like, I don't really, in terms of this, I don't really want to treat them too separately in that way. So what I want to do is I want to work on a way to just flatten that out. I don't really care sometimes how I got to the leaf node result that I've got, right? I just care that I got there. And at this point, I can use the flatten function. And we're going to remove that. And I'm just going to refresh the bone colors by walking through the levels there. And we can see now we immediately go from one whole column to a bunch of leaf nodes, right? And so now the simulation will be the column's going to hit the floor, then it's going to break into loads of tiny pieces. So the next thing we want to do is we want to try and moderate that process. We're going to be releasing a lot of rigid bodies, and of course, if we were doing that throughout an entire structure, we're looking at potentially thousands of pieces all being released at once. So to do that, we're going to work with clustering. So we're going down to level 1 here, and I'm going to show you a nice little trick. Eventually, this will be consolidated into the UI, but for now, we're going to use a command called geometry collection print detailed statistics summary. And hopefully that's going to have a think. Yeah, we can see it here. I'm just going to clear that log a second, just run that again. There we go, that's clearer. Right, so here we can see level 1, we have 313 pieces, right? So now I've got my number. I'm going to try and bring that down to a fraction of that. So let's drop that to say 100, right? And I'm going to hit auto cluster. And what that's going to do is it's going to search through those and it's going to bind them together. So now we're starting to stick all of those Voronoi cells together. And now at this state, we can release, 100 pieces rather than 300. And again, let's do that again. Let's drop down a bit more, half that. Start binding those together a bit more, and then let's say 15. Let's go with that. And there we go. So now we can walk down through those, like so. I'm just going to close them in a bit, and you can see this is effectively our breakup pattern.
And each time that
Right.
you do that auto cluster, it's also creating a new level for it, correct?
Correct. Yeah, that's basically now building that into the hierarchy. If I was to, go in and fracture sub pieces at this point, it would always insert an extra level to allow for that. And again, that's why we have the all levels ability, so that we can, be able to see everything at once. But this is obviously going to be pretty crucial in terms of how we simulate this object. So let's close this down and let's work with this object. I'm just going to save that real quick. And there's a couple of things we can look at. First of all, we can look at the way it's going to collide, and we can also look at the way it's going to break up. And what we're going to do is we're going to switch to a level set collision. And before we do that, let's just describe what level set collisions actually are. So rather than wrapping this analytic shape around the object, what we're doing is we're rasterizing it. We're going to apply effectively a voxel grid, and we're going to sample the shape within, and we're going to come up with a kind of a virtual representation which looks something like this. We're going to look at a live example in a little while. The resolution of that really determines the accuracy of it. It's going to scale cubically in memory as well, so there is a footprint to account for here, but it does allow for some really cool stuff to happen. You can see here in this example, we have different resolutions, 4x4, 8x8, and you can see at 8x8 in the middle there, we're not actually picking up the whole of this torus shape. And then by the time we get to 16x16, we're getting it loud and clear, right? So the level sets allow us to control and tune the quality of the collision that we're going to work with. And typically, we get a much better response between the pieces. There's a lot less intersection, and this is generally how we get the really pretty sims. But there is a cost to that. So I would say that generally in most game examples, you're probably going to want to try and lean towards simpler things. But where you absolutely are going for pristine quality, say for a cached simulation, this would be the solution. So let's do that to this one here, and that's pretty easy. The other thing I'm going to do is I'm going to just change the mass of this. We're going to use mass as density. Let's put this up so that it behaves like rock. 2300 kilograms per meter cubed, I believe. Should get us where we want to. Now you'll notice I've done all this before I've swapped this to a level set. And the reason for that is because every time we change a property at the moment on one of these objects, we're going to rebuild the level sets, and there is a build cost to that. Level sets are going to be stored inside of your derived data cache, and there's a time sink to that. So like for the first time you load up a map, you'll notice this with the content examples. The geometry collections map in particular is very heavy. There's a lot of stuff going on there. So it'll take a while to load up for the first time while it builds those level sets into your derived data cache. So let's do that here. This one isn't too complex, so I wouldn't think it'll take too long. So we'll just change that now and wait for that to pop in. There we go. And we'll save that so we don't have to do that again. And now we're going to simulate that and see what happens. Okay. So right now, it's all kind of collapsing under its own weight. You'll note that there wasn't really any strength to that breakup. And the way that we control that is we're going to use this damage threshold setting here. And we can have a look again using our output log on how many levels we've got, or we can have a look over here. We can see that we've got 5 levels in total, right? And I can control how many of those levels I can release at any one time through using max cluster level. So if I put in 1, you'll remember we clustered this back to 15 pieces. That's all this should be able to release. And there they are, right? And you can also see another thing that's happening here, which I alluded to earlier. Did you notice how those started rolling through the floor? Kind of obvious, right? Again, that's what I was saying, where we have all of those pieces together right now. But they've only got 60 particles to test with right now. So let's ramp that up. That's probably going to cause the level set to rebuild, but hopefully it won't take too long. Save that. Let's see how that affects our result. That looks a lot better, right? So effectively what we're going to do is we're going to look for a way to control the point at which these objects break up, and this damage threshold setting is where we do this. If I set this to something really, really high, like say 5 million, that should do it, I would expect this not to break at all. So it's really a case of trying to tune this object and control the point at which it releases all of these rigid bodies. So let's start doing a bit of guesstimation. I'm actually going to allow 2 level breaks here. I'm going to start with something like this. Now this number is determined effectively by the weight of this thing, the mass of it. Like if this is a lighter weight thing, it'll crack under lower numbers. So generally you're tuning the resistance to make sure that these heavy pieces don't exert enough strain on themselves to break apart. And so that's really just a tuning thing. There's no sort of perfect number for that. But you see how that sort of, it caused a connection to break between some of the rigid bodies on the way down there, but managed to hold its force, or its form rather, and then when it hit the floor, it was just enough to push it over that. So that's really the key to kind of controlling how this stuff works. So I'm going to try and dial in something that we like. Let's see how this feels. Yeah, that feels pretty good. Okay. Now, the dynamic state of this is what we currently have this set to. Bear with me one sec while I find this. Yeah, okay. So here in the object type, you can see by default we've set this to dynamic. And that means it's going to fall no matter what. If I wanted this to stay still, I'd switch it to static. And then when I hit play, it stays exactly where it is, but it's not doing anything at all. What we want to do is we want to create the ability for this thing to stand up, but also be kind of dynamic too. And the way that we do that is we start applying what is known as an anchor. It's actually possible for me to wrap a field around this object and just physically just say, you're not static, you're dynamic now. But in order to get some of the more important destructive behaviors that we're looking for, i.e. if I punch a hole through the middle of this column, the top of the column knows to fall down, we're going to use anchoring to do that. And we're going to build a connection graph and effectively create some kind of world support logic that's going to allow us to do that. And so this is where we move into the realm of fields, which is the other really important paradigm that we'll be looking at here. So in order to work with a field, we go into the physics here and we add ourselves a field system.
You also need to enable this plugin if you've downloaded the source build and follow the steps online. I don't think it's covered in there to enable fields. Some people have picked up on it, but we should update the forum post if you want to work with fields, or Niagara as well, enable those plugins.
Yep, they all need to be on.
Absolutely. So a field. What is a field? Well, I'm going to drag that out into the world, and at the moment, what this is, a field is a region of space, and we sample in that region, and we can affect a physical property, right? And so by default, by throwing that in there, what I've actually done is I've introduced it into the world, and it is telling absolutely everything, absolutely nothing at this point. And what we're going to do is we're going to set this up as a blueprint. So I'm just going to add a blueprint here and turn it to that. And we are going to tell this field, okay, right, where exactly are we going to affect and what exactly are we going to do? So let's just drag this component out here. Now we're going to be building an anchor field, and I should draw one key distinction here. The anchoring process happens before the sim starts going. So we're going to do the anchor field inside of the construction script. What we're basically saying is we want you to build these before the sim is going. And then we're going to affect the connections that it creates, on tick or begin play or whatever. So the first thing I'm going to do is I'm going to quickly add a reset field system. And that's just going to mean every time I move this thing, it's just going to refresh, the connections inside of it, and it's going to resample the geometry that it's overlapping. And then I'm going to do add field command. Now the add field command is, again, a construction sort of based statement. Typically, what we would usually use is an apply physics field. Like this, and you'll see that they look very similar. And I'm drawing attention to this because it's very easy to get very used to using the apply physics field and then come and try and do it in the anchors. I'm not saying I've ever done that and made that mistake before, but yeah. So an apply physics field is going to do that during the sim, and the field command is going to stack that up beforehand. And you'll see they look very, very similar, and they can affect all the same kinds of fun stuff, right? So we're going to do that, and we're going to enable that. And so all we're saying right now is, okay, field system, you are going to affect dynamic state. But right now, we're not telling it how or where. So let's start doing that. And for this, I'm going to make a cube, and I'm going to borrow the transform of this. This is so I can visualize where the field is, right? And now we're going to add a bunch of fields together. Okay, and we're going to start adding these field components. So the first one I'm going to load in is a box fall off. And drag that out there. And then what I'm going to do is I'm going to type set field. And I'm going to add that there. So here's the box, and I'm going to borrow the transform from this static mesh, which is a meter cube. So perfect for my needs here. And that's an area I'm going to work with. But the thing I actually want to do is I want to change the dynamic state. What I'm going to be doing is I'm going to be overlapping some of the rigid bodies inside of that geometry collection, and I'm going to tell those ones to be static. And all of the other ones above it are going to still be dynamic. And so they're going to know that they are statically anchored. And they're going to know that when we break any connections to them from that static anchor, that they can fall down, right? So to do that, I'm going to add a uniform integer. And again, set field. Now I could actually just type in a number into this. In this case, 3 would be static. But what we're going to do, just to make it a little bit tidier, so we're going to make ourselves a variable. We'll call this static state. And then we're going to change the type of that, and we're going to be looking for object state, right? And I'm going to compile that. We'll get a warning because at this point it's not set. So let's set that to static, compile again, and we can drop that out there. And then I'm going to use a toInt to be able to convert that and put that in there. Now I could actually plug that straight into this field. And the other thing I need to do with an anchor is I need to tell this object that it is connected, that it needs to use this to initialize itself, right? Because we're going to have a lot of anchors in a world, so we don't want them all affecting everything. So the way we do that, you'll notice we have initialization fields here. I'm going to look for that anchor and connect that. And actually, let's lift this off the ground so that we can see that clear distinction. And I'm going to hit play. And you can see immediately it isn't falling down, which is good because, yay, that means it's anchored. But you can see the problem is I'm not overlapping it. And that's where a culling field is going to come in. So we're going to add that now. Bring out a culling field, set field, like so. I'm going to drag that in there. So what I'm going to do is I'm going to use the box, and I'm going to say, I want you to cull outside of here. By default, we're actually saying the opposite. We're saying I want you to forget everything that happens inside this box and only deal with the outside. So let's swap that round, right? And then I'm going to push this through here. And now, inside of the box, we're saying you change your static state, right? Now, culling fields are super important in a bunch of different ways. Even if we were to create a field event through a normal box fall off, typically we'll be dealing with the magnitude on the inside, and then everything on the outside is this default value here. We also have fall off abilities here, like linear fall off and so on, so that we'll be blending from whatever the magnitude is to that outside value. In something like this, I want to basically limit leakage from this field. If it's saying, I mean, it can basically be saying 0. It can be saying absolutely nothing at all, but it's saying it to everything. There's a computational cost to, even saying nothing to all of these rigid bodies in this world. So by culling it, I am just telling this field, I just want you to consider what happens inside of the box. Everything outside of it, forget about it, don't compute it. Right, so there's that. And while we're at it, let's put something a bit more see-through on here. Let's try that. Okay. So here's our anchor volume. And let's give it 3 meters by 3 meters. We'll make it a cube, why not? Just bring that in. I'm going to overlap that. Now, it's important to note that what we need to be doing is we need to be overlapping the center of mass of something. And by that, I mean the leaf nodes. So if I bring that down, we can see that's happily going to be grabbing these lower pieces here. So those will switch to static, like so. And then when we hit play, it doesn't fall down, which is good. But hopefully, it's too strong for this gun, hang on. We should be able to destroy it, right? That gun's actually tuned for a different example, which I'll be talking through in a bit. So, okay, so now that this is standing up, we want to be able to force it to break. But also, we want to have a sense that other modules are sort of part of that same structure, yeah? At the moment, they don't know about each other. In fact, if we just bring them out here and hit play, you'll see they'll, oh, hang on. Oh, I'm an imbecile. I'm still on static. Okay, let's set that dynamic. There we go. Right, so you can see how they slid off of each other right there. They don't know about each other. So what we can do to combat that is we can use the cluster group index, right? And what that does is it just gives them a shared ID, and it tells them, yeah, you guys are all part of one construction, so build connections between each other and behave as one thing. And to see that happen, really will ramp this value up so that they won't break. And you can see that they're all behaving like they're one thing now, right? And that's really the key to, how we put these modular things together so that we can, build up to something along this line where everything's being anchored, it's all bonding together, and then we're applying these fields to force things to break apart in, whichever ways we decide to set up.
On the cluster group index too, I guess you could also mention that the damage thresholds can be tuned for individual pieces within that index. So
absolutely,
the top piece could have a different damage threshold than the bottom piece, so you can get that trickle down type of effect.
Right, exactly. And in a way, what we've kind of got here is really a destructible lodding system, because you can see, if I just remove that relationship in the cluster group index, I have the same geometry collection authored the same way, but for my purposes, I may never get close to that one. So there's not a lot of point in me releasing 300 rigid bodies, because I'm not going to be able to really draw all that, you know what I mean? Especially once we start adding, particles and stuff like that. So why don't I just reduce what that's able to release, and then I can tune that a little bit, although of course I've got to set that number back down. 5 million's quite high, isn't it? You see what I mean? And it's like, I don't really notice that this one, has the potential to break more than this one does, because of the distances involved. So, being able to tune that stuff is one of the really core ways to being in control of what, the physics thread is doing. And it's actually, while we're mentioning that, it's worth noting that, when you are tuning these things, it's the physics thread that we're interested in. So I'm going to come here and I'm going to put stat chaos thread. And this is our physics thread. At the moment, the FPS there's like somewhere in the region of like 30,000 frames a second, which I'm going to say isn't true, but it's because we're paused. So let's resume that, and that's settled now to about 100 frames a second. Okay, and the more that stuff happens, the more that number's going to start coming down. In this other room, we've actually got the same sim, but this one is cached and then run through a level sequence, and you can see it's not really affecting the physics sim now. We've taken the load off of the physics thread, and so the FPS stays pretty consistent. But if we spin this one up again, it's going to take a little while, because in this initialization stage, we're just going to be building up all of those connections. So the game thread typically will kick off first, and what we'll see is the physics thread will be busy for a bit, and then suddenly you'll see it stabilize. So here we go. So that's now settled out to 180 frames a second at the moment, which is basically saying I'm not really doing anything at this point. And as we start, causing physical calculations, we'll start to see that number drop a little bit. With something like this, we're going to start to see it drop quite a lot. And the key is trying to tune those damage thresholds to control what we release, how much we're colliding in one state. And we can see at the worst case there, we drop down to 48 frames a second before returning and stabilizing back out at 115 roughly. And that in this case isn't really an issue for me, because the purpose of this sim is to cache it. But in terms of gameplay stuff, we're going to be watching that and tuning all of those values to work with that as best as we can. So yeah, we've got an object there, and we can stack it, and then we can tell it to be part of a single object. Put that there or something. And we'll grab those. We'll set their cluster group index 2. And actually, these ones I don't need to worry about initializing through that anchor. I've duplicated from that, so they'll probably be looking at it. They don't really need to worry because they're not overlapping with it. This is the one that cares. And now I'll hit play, and everything stands up. And so there we have a unified structure, right? So what do you want to do now? Should we make it fall down?
That's what we're all here for.
Apply some strain to it using a strain field, maybe?
Exactly. So what we're going to do is we're going to add a strain field. Now, this one I have prepared already. We can have a look at what this is doing. It's worth noting that we've got in the content examples a whole bunch of fun field setups for you to try. These ones kind of walk through the principles of various different ways of exerting forces and so on. And then we've got these slightly more dressed up ones with a few bells and whistles thrown in for good measure. This one is a strain field. And just going to place that where we can see those values. Actually, let's set that up. It's been set up so I can see exactly as an artist where this field is going to influence. And you'll notice I've set the magnitude of this thing to like 4 million. And in effect, what I'm doing there is I'm saying you are going to break no matter what. If I'm overlapping this, you're breaking, right? And let's go in and have a look and see how we're doing that. Okay, and again, all these are going to be nicely annotated so that people can follow through, how they're constructed. And the place that we're doing that, and remember, this is now a physics sim part of fields. So this one's going off of begin play, and then we're running a delay. And we are going to be working and applying a physics field here, and we're going to be bringing in an external cluster strain influence onto that geometry collection. The way that we're doing that, it's very similar to how we built up the anchor. In this case, we've got a sphere, the strain volume, which I've got the location of and the radius of. So I'm using that object, which I'm using to visualize, to drive what this is doing. And again, we've got a culling field here, right? Here's a radial fall off. I've added these extra names so I can tell them apart over here. But you'll notice that I haven't made a radial fall off and then plugged it into this one as well. And it's because they're doing two different jobs. I'm evaluating them all together. So each time I'm setting a field, I'm going to give it a field asset to set. And then we're going to combine those things together. We're using exactly the same radius for both. In this case, I'm just saying I don't want you to calculate that you're not, applying strain outside of this. So just forget about the outside and apply a magnitude in here of external cluster strain inside of this sphere. And then what we're doing is we're also setting up an explosion. And the way that that's happening is, again, we're using that same radius. This time we're using a bit of fall off, right? And we're multiplying that through an operator field together with a bit of noise to just put a bit of variation into what that is. And that's just defining that region. It's kind of a starburst with a bit of noise in it, but it doesn't actually explicitly determine direction. We use a radial vector for that. And again, we're going from the same position. And so now we're using a vector to drive through that same region that we've defined, multiplying that result together, again, culling it just to keep it contained, and then we're applying that to linear force. And we're using linear force rather than velocity because we want to take into account how massive something is. So you saw earlier when I was shooting my gun against that, it wasn't exerting enough force to break that thing apart. And we're also just connecting to angular torque just to try and get a bit of random spin variation in there. And so that's really what that's doing. And you'll see it's very, very similar to how we set up the anchor field. And we're just applying a physics field and just choosing what exactly we're going to target. So let's see what that does. Actually, hang on, give me a second. Let's debug this one, turn it on. And we can watch it. And I'll just reduce the delay to about 3 seconds. Okay, so after about 3 seconds, boom, there it goes. And it all comes down. And actually, it's probably breaking up a little bit aggressively. So what I would probably do in that circumstance is I would start tuning those damage thresholds until I'm releasing, seeing more interesting breakups. I want to see large pieces cracking off to begin with, and then as they cause extra collisions, start releasing more and more small pieces. Basically a controlled descent. But one of the interesting things while we are releasing a lot of pieces here we could look at is we at this current point aren't telling this thing, to settle down yet, right? So what we can do is we can create a disable plane. Now, how are we doing on time? Have we got time to walk through one of them?
I think so.
Yeah, we got time.
Okay, because we've got ones we've made and we can build a new one. So let's build a new one. Okay, so we're going to call this disable field, right? Or field disable. And I'm just going to save these just in case. Okay. So again, drag that one out. Pop that in there. And for this one, we're going to use a plane. We're going to check against a plane to determine whereabouts we're going to start setting our threshold. Sorry, I'm double clicking it. It's over here. Now this one is going to run throughout the sim. And so obviously I need it to constantly be evaluating. So we're going to run this one off of event tick. And what we're going to do is we're going to apply a physics field. And we're going to bring ourselves in a plane that we can borrow. And what I'm interested in with this one is I want to get its location. Actually, give me that. Thank you. And I also am interested in getting its up vector as well, see which way it's facing. All right. And then we're going to add a plane fall off field to that, because this is what's actually going to be doing it. This is how we're going to visualize it, right? I'm going to there we go. And so here I can put in that position, up vector, right? Now, the threshold that we're going to be checking against will determine through this magnitude value here. You'll also notice that we have a distance setting on the plane. And this is basically where are you going to check to, right? Because obviously if it's an infinite plane spreading off, you know, laterally, we also kind of need to know where it stops. And that's useful because then we can multiply things like gradients in using that distance. So yeah, we may as well set ourselves a distance variable here. And we'll make that one editable and expose that so that we can tune it inside the world. And then again, what do you reckon we're going to add next? Going to throw in a culling field as well. Because effectively, you know, what this is going to be doing is it's going to be setting everything below the plane set to the distance that we specify. It's going to be checking for that threshold. And then above the plane, it's going to not be doing that. And it's important again to cull this, because if there are other disabled boxes and fields in other parts of the map at higher levels, we could be telling them not to check, right? So we want to make sure this one particularly does not leak. So I'm going to use that again. I want another what am I doing? Sorry. Looking for a plane fall off field. So we use exactly the same settings, yeah, to determine that culling. And we're going to cull the outside and run that in. Now, this is going to be a disabled threshold that we'll be checking against, but let's see it first and check whether it's working by using kill. Kill is far more aggressive. It's instant. Basically, what it's going to say is if the center of mass travels through me, immediately just drag this out of the sim. There's no threshold. It's just stop. So we're going to see whether this is working using that, right? And so we've got our height here. It's going to be infinitely spreading off at this level. One thing I want to just check real quick is the distance. So I'm going to give it 5 meters below it. I'm going to bring this up real high because some of the things we're going to be bringing down here are going to have their center of mass. Now, the center of mass is for that current rigid body. So if it's the full cluster of this thing, the center of mass will be here somewhere, right? It's only once we start releasing those smaller pieces that we're going to... And you see immediately all of those pieces, as they're released and falling through that plane, they're just stopping. And those are out of the sim now, yeah? So we can just switch that behavior to be a disabled threshold. And it's going to look for basically a certain speed that we define. And then it's going to slowly move things out of the sim. And so we're going to want to set a variable there for that, which we'll call threshold, and we can tune it. see what feels good. And so to start with on that threshold, let's set it super high. And we can bring it down a bit lower now. See what we get. Okay, so you can see things are stopping quite suddenly. Some of them not quite into the threshold yet. And there it goes. It stopped. Looks like it. Doesn't seem to have, actually. That's quite goofy. I think maybe I've got it too high off the floor. Okay, so yeah, so that's disabling, and that's another way for us to pull things out of the simulation. Disabling them means I can wake them up again with more field interaction, but it means that collisions aren't going to constantly keep waking them up. If you want collisions to be able to reactivate things, then you would use a sleep field for that. We'll have an example of that in a moment. Basically, I think that is pretty much the basics of this. I think if you've got a grounding in those essential things, that should set you kind of where you need to be to start experimenting with many different combinations of fields and behaviors. Those principles are pretty much what are going to govern how you do that. So playing with those strain values, affecting them in different ways, applying velocities, forces, and so on. And just learning how to gather these pieces together in this way means you can start building all kinds of structures. So that was really what I wanted to convey primarily today, and hopefully that'll set people getting started.
Hey, Jack, also, I think it's covered in the content examples as well, the performance implications of kill, sleep, and disabled. If you can touch on those really quickly. I think it's covered in the content examples, isn't it?
Yeah, it is. It should be. Yeah, I mean, basically, as I say, like the performance implications are like, I mean, kill is
going to just
super
kill
cheap.
it, so that's going to be
Kill's they're just gone. They're never to return. Sleep would be the more expensive of them because, as I say, any collision, and it's also a little bit more erratic in terms of you can have collisions going on, micro ones, and so it just settles things over time. But it also means that you can wake them up with other objects falling onto them, and it also means that things will stack up more, that kind of thing. But it's definitely more expensive. And disable basically says, okay, I've gone out of the sim kind of temporarily. Collisions aren't going to affect me at this point, but if I apply a field and say wake up, and you're actually being exploded at the moment, it will wake up and off it will go. So yeah, typically you're going to work based upon what it is you want it to do. In this case, you can see I've got a disabled plane right here, and it's just because as this stuff starts to stack up, you're going to have a whole load of things being released. You've also noticed that there's a disabled box inside of this thing, and that's because inside the building we've got floors, and so there's going to be a bunch of rubble landing on those and sort of quietly battling and colliding against each other. So we settle that down nice and quickly until I need it again, and that just helps keep that separate. You can also do things like, for example, I think over here, so you'll see here we've got a collision group ID of 1. And I'm thinking that this one over here is probably a different one. At the moment, it's still using the same one. But okay, what we could do here is if we want to, if I'm saying, well, look, the geometry collections over here are going to release pieces that on this side of the building, we're never going to, bounce against. There's no point in checking to see whether they will. So by putting them into a different collision group, they'll never try and do those checks. These are the sorts of little refinements that we can do. And another thing that's important about this one is we have here a solver. And the solver is where we're going to start dealing with the iterations on testing for collisions, correcting push out, which is to say when things are intersecting and it can't resolve a collision, generally it's going to try and push those apart until it can. How vigorously our clusters are being connected, because sometimes it's possible when you're building that connection graph, you'll see that it's managed to sample a few things that and it thinks they're together, but they shouldn't be. So we can start weighing those values down until we get the behavior that we want. By default, actually, the cluster connections, which you can also set within the geometry collections here, we use quite a lightweight solution default, which is the point implicit one. We've got a few other options here which you can try, which just basically attempt to kind of filter and remove redundant connections if needed. So those are always worth sort of working with to try and tune to the best result that you can get. But yeah, it's a fairly involved process trying to get things to work absolutely as you want them to. But everything is within your remit to do so, because you're able to sample literally anything, anywhere, anytime, and tell it what to do. And that's a level of control we just haven't had here before. So it's huge.
That's great. Thank you so much for showing us a little sneak peek at the content examples and going through some of the fundamentals there. We have a lot of questions.
I can expect.
Okay.
But a lot of them are really good, though. So we're gonna try to walk through them here one at a time. First off, I wanted to start.
Sure.
There were a lot of questions just in general about the content examples and sort of regarding 423 and Chaos. Will 423 Chaos assets and saves going to be usable in future UE4 builds?
I don't know. I mean, I would say so.
I would expect.
Yeah,
so.
that's kind of
I
a
would expect so
Lentine
that
one.
it's future proof. I don't
I would
think we will.
expect so. I mean, yeah, I mean, early stages, we would have to sort of reauthor geometry collections and so on. But I haven't had to do that for a long time. Generally, we've been able to just march forward and evolve. So it's been a while since that's ever had to be a problem. So I don't foresee that, but I can't promise not. It's fairly robust, I think, at this point. But it is really worth reiterating what Lentine said in the 423 live stream, that we don't consider this to be production ready right now.
Yep.
Chaos is our physics system of the future, but right now it's a destruction system primarily, and all that other foundational stuff is being worked on and implemented. This is just a really good place to start, getting all those collisions working as we want them to, making sure that fields are reacting as we want them to. So, part of the reason, this is out as an early access is because there are so many use cases. And as you've seen, there's a lot of field options for you. And so the possibilities and the combinations of those is just, we're not going to hit them all. And so, this is why the community is so great, because they're going to have all kinds of things they want to do, and they're going to try. And sometimes you're going to hit brick walls there, but tell us, because that is the data we want. That's exactly what we want to do, and we'll evolve it together. And I think this is going to be super powerful. We've got a load of really cool things coming down, down the line, which aren't in yet, and it's going to be wicked. It's going to be really, really good.
Yeah, they were wondering about when the content examples will be released, and as far as I know, it will be released when 423 goes out of preview,
It's
right?
scheduled to go with that. I think we'll have some documentation on that regarding that as well, because you'll have to build that project off of source as well.
Right, and that was another one of the questions was, when 423 gets released, are they still required to build the project from source? Chaos will not exist in the binary build until it comes out of beta.
As far as I know, yeah.
But we've got a bunch of really good content example maps here, covering as many topics as we could hit in one thing. So we've got some nice examples of different ways of fracturing. We've got examples on different fields. You've also got all those field blueprints. So by all means, take them. Frankenstein them, turn them into whatever you like. that'd be great. I'm really interested to see the things that people come up with in that respect. We've also got some pretty good paired back examples of things like the gameplay map's a good one, to check, to show you some of the logic that's involved. I'm going to just turn this chaos thread off. So ways of detecting things like we have break and collision events, right? So you can see here we've got this little actor over here who's monitoring this geometry collection. I'm going to just fire a field at it and break it, and you'll see how that thing saw that happened. So it noticed there was a break event in that and picked up on that. We're able to do things like we're able to generate mass through that and figure out what those numbers actually are. You know what I mean? By testing, what these objects are doing. And then similarly, like the key, you'll notice in the chaos demo that we put out, there was all kinds of dust and explosions and fun stuff going on there, and that was leveraged through a similar way by talking to Niagara and using these systems to basically say, well, look, I'm going to look for break events and I'm going to spawn particles where those occur. And so there they go. And then let's throw some collision events into that. And so there's the collisions in green and the break events in red. And then, I've got something traveling. It could leave a trail behind it, right? So we've got trailing events as well. And so let's see those blue ones start to appear as, velocity happens. So, you can visualize that those could be, pieces of rubble falling away. They could be pieces of dust and smoke clouds and all kinds of good stuff. So the geometry collections map and the fields maps and stuff, we're just really showing you, what you can do with the geometry collections. It's just a very honest, this is just rigid bodies falling apart here. You augment it using all this other stuff, and we've added examples there to help you get started with that. And also, there's, I think, like at the end of the gameplay one, we've got an example of a line trace against a geometry collection here, which is being used to spawn a field, like so we can check against them and start making, weapon type effects as well. Again, the sort of the weapon aspect of Chaos is pretty early at this point. Obviously that's going to improve as we sort of, work into it. But I had seen some people were asking about that.
Mm-hmm.
Yeah. Another question, there were several actually around sort of multi-layering, doing rebars inside the concrete. Is there a way to handle that?
Well, I mean, we've done that ourselves. There's kind of quite a few ways you could go about that. I mean, if you had a geometry collection with something built into it, it's going to start off with those unfractured. So there's no reason why you should have to apply the same fracture pattern to the outside as the inside. But I mean, you also could just use separate geometry collections. I think in the GDC demo, we did that in those first kiosks where we had like concrete pillars with rebar on the inside, and then we had tiles on the outside of them. Keeping things as, there is a cost to having more geometry collections, but the thing about that is it means that we can tune their strengths independently from one another, right? So if I've got, for example, a glass window, I don't want that to be as strong as the rest of the stone around it. So I would generally keep that separated and give it its own damage tolerance, which is exactly what's happened inside of that geometry collections map that we were looking at a moment ago. But they can all still belong to the same cluster group index, so they can all still be connected the same way, but just behave differently. So that's what's going on here. Like if we, sorry to whiz the light speed through there, but you can see this has its own damage thresholds. I've actually set these really super high to begin with, because I don't want to bring the whole building down. There's actually, like when I cause an explosion, if we tune all these things to fall apart nicely, the chances are they're going to fall from above and land on one just like it, and that's going to be enough to bring it all down, and you get this cascade. There are actually really cool ways of actually using fields to augment the internal strain strengths of these things, but I think that's probably for a later podcast. But you'll see there, that's really strong, and the glass isn't, so I expect that to break pretty instantaneously. Keeping things separate in that way just keeps things fluid, and to be honest, it doesn't take long to if you kind of think of a better thing to do, it doesn't take long to test it and to author it. The tools are pretty fluid that way.
That's great. We got a question from the forums, and I'd like to take the opportunity to let everyone know that if you have questions before the stream, you can always go ahead and ask them on the announcement thread. And this one reads, if you make a large rounded wall surface or a hollow tunnel to walk in, can the new collision be made to be closer to the complex collision? This was a limitation with the Apex instruction meshes.
It's almost like I was telepathic and foresaw you would ask me that one. Yeah, no, I saw that question. And so what I've done here is it's actually a really good question, and it really does lead on to another useful thing that I really, really want to show people. Because, of course, we're dealing with level sets, right? And level sets are a kind of a mysterious, esoteric kind of term. That these, what are these level set volumes? What do they look like, right? So just start this off here. And you can see these are level set objects here. They're set to be static. They're not broken up. They just have, level set surfaces on them. And so the answer is yes, you can. But let's look at what that actually looks like. Now, I'm going to pause that, and I'm going to eject out of the character. Now, actually, what I'm going to do is I'm going to deselect everything, and I'm going to do that. I don't know why I'm quite OCD when I'm in the editor, so apologies for that. Right, so you can see here during the sim, and these need to be checked while we are simming. We can't do this just in editor. You'll notice we've spawned a few things here, and the one we're interested in here is this geometry collection debug draw actor. Now, it's important to note, in order to see what a level set is doing, we're going to add a command which is show flag dot post process, and then we're going to put space 2. That's just so that we can display the material we use to render what a level set is. But I've got the debug draw actor selected here, and what I'm going to do is I'm going to come down here and I'm going to get the IDs for these objects. At the moment, you can see I was testing this earlier on, so I'm going to remove that back, and we can see there's a number on each one of these now. I'm interested in checking out number 1. So what I'm going to do is I'm going to show rigid body collision. They're all going to disappear. The thing about level sets is we check these one at a time. Not so for cubes and spheres, they'll show up. But let's put that ID in. And you can see here we have a visualization of the result that's actually being returned for this one. And that allows us to walk through our geometry collections. If you've got something that's behaving a little bit weirdly, you might be able to identify why that is by being able to, go into that cluster ID, just as I did there, and see what that is. And I can turn off hide with collision there, and I can see this is where it sort of falls in terms of the actual piece of geometry that it's representing. And just like I said before, with the how we're sampling these, the resolution will determine how accurate that is. And so you're trying to tune it until you're happy with the result that you get, right? And that's going to be a good way to do that. So hopefully that answers your question.
Yeah, it certainly does. And you'd be able to make a cave wall or something similar as well,
Yeah.
and just tune that resolution.
Totally. Yeah. And I mean, this is pretty much behaving the same way each time. And yeah, it seems quite happy to roll around that thing. Sorry,
awesome.
anyway.
There was another question, which is sort of in general around the calculations or the simulations that we're doing. Is any of this based on real-world physics, or is it all video game to the point of abstraction? Like, can you do simulations for any kind of scientific study?
I would want Lentine to probably answer that one. It's a good question.
Mm-hmm.
I'm not sure if we're at scientific study levels just yet. I don't know, but maybe we are. But yeah, that's probably one to follow up with Lentine.
We'll see if he's been answering some questions in chat, so he might be able to get that. That one, I think, happened a little bit before.
Hopefully he's hearing us and he can chime in there.
Yeah, let's keep going. We had another question. Is all of this tremendously resource heavy? Do I need to upgrade to a Watson level computer? That's what they're asking. Do you want to let us know what you're running it on?
Right. Well, I mean, it's as resource heavy as you make it, right?
Mm-hmm.
Like, I mean, yeah, if you're going to release, 500,000 rigid bodies all in one moment, I would expect that to chug a bit, right? But this is kind of what I've been trying to show here. It's very much, it's about how you tune it.
Right?
You'll remember I showed you the solver as well earlier, like this thing here. These objects can be attached to one of these, so you can spread the load between different solvers if you want as well. That's another good way of tuning that. Like, for example, like the iterations on how many collisions I'm checking for to make sure that's super accurate. Here I've pushed up to 4 for that because I want to make sure that I get a really nice sim. But I might move into another room where I don't really need it to be that accurate. So I might as well just put all the stuff in there onto a separate solver and separate it from this. And that means they're never going to try and talk to these pieces that I just left behind. You know what I mean? Like it just kind of ring fences them into their own little place. So it's really down to the user to try and find the most performant way and to work with the system that way. But it's pretty flexible in terms of what you can do. And as I say, we had a pretty pokey machine at GDC, but it was totally purchasable at the moment. It was a high-end gaming rig, and we were playing it live. We keep doing it. We're playing it live. It's fine.
That's good.
Anything else?
Yes. We got more.
Okay, I'll settle in.
When the calling field, when is the calling field populated? Which moment of execution?
Well, I guess once the I don't know, like specifically the color. I mean, it's all going to be evaluated and stacked up as the same event as to quite what it's doing under the hood in a finer grain than that. I'm not sure, but yeah, like effectively the culling field it's all part of that same combination, and then it's applying a physics event based upon all of that information. So it's all happening, at that point, depending on what we've set it to do it on, whether it's begin play with a delay or if it's on tick, then it's going to do it on that. Like, obviously on tick things can be quite expensive. Like if you start applying forces on tick, that's going to be a lot of forces, but you might do that for things like, there's a really good example in Jim's map on fields, I believe, where he recreates sort of strain over time and starts feeding a noise pattern of just breaking connections over time, and effectively what it's doing is it's decrementing from that threshold until things start to fall down. So there are ways of doing that, but typically the culling is necessary just to know that we're not going outside of that area. I don't know if that answered the question at all, but yeah, that one's a bit left field for me, I'm afraid. I'm an art monkey, so.
Is it possible to bond cluster groups to different indexes, like 1, 2, 1, 2?
Not at the moment, as far as I know. Not at the moment.
All right. And here's an easy one. Oh, I'll continue.
No, I just think at the moment, yeah. I mean, I'm hoping that may be possible down the line. I think the same needs to happen with collision groups too. Because I think then it's a little bit like how we treat smoothing groups, where you can kind of go, this one over here is 1, and this one is 2, and this one is 1 and 2, because I want this to collide here, but I don't want it to collide over here. You know what I mean? So you can kind of set those collision blends happening. I think we probably will have to add that at some point, yeah, but not right now.
Here's an easy one. How did you change the color of your folders?
Oh yeah, no, I told you I'm quite OCD, and sorry for the color splash. But basically, yeah, all I do is it's just up in here, set color, add yourself a new color. You start having yourself a little palette here, and I've been applying the same things inside of these. Just such a visual thinker. Do you know what I mean? Like it just helps. It helps. It's useful. I think Wyatt's a color buddy as well. He does it too.
Yeah, I was saying on that same topic with fields, setting a thumbnail just to give you visual representation of where it is in the level is super helpful too.
Yeah,
actually cover that in the docs.
definitely.
It's kind of like a best practice thing.
For sure, and also like with maps as well. Like it's interesting. I wonder if we've got the. I don't know. It'd be nice if we had the existing maps for the building maps. Typically, I think I might have a few examples kicking around here. Yeah, you can see. In some of these other things, this is just in a sort of personal version of this where some of this stuff isn't checked in, but like, yeah, often it's nice to kind of keep, for example, if I've got a cached sim state, right, to keep that on a separate level from the same exact thing, which is set not to play back a cache. So what I mean by that is this here is the version I'm going to cache. At the moment, there are limitations. The cache system is a real baby system at the moment. But in order to play it back, like I said, we typically we use a level sequence to line all the caches up inside of. So I can show you those here. It's certainly something to factor in when you determine how many separate geometry collections you've got in any one building, because obviously the more you have, the more of these you've got to manage. But basically, when we're playing back a cache, we're going to use a kinematic state to determine that, right? Because it's going to basically, we're saying you're not dynamic anymore, you're kinematic. You are going to look at those bone transforms in the cache that you have associated with you, which is here, and you're going to play those transforms back to us now. The fun part of that, down the line, we haven't done a lot of experimentation on just yet, but guaranteed we're going to see a lot of it, is that because we've taken the load off of the physics thread when we're playing back a kinematic playback, what we can do is we can apply fields to, say, to rigid bodies. So if I fire an explosion into all of that mess, I can have that field say, all right, all you kinematic rigid bodies inside of this, you can be dynamic and just fall down now, right? And from an end user perspective, they're not going to know or be able to see that isn't a dynamic simulation just happening in real time right now, because they're able to actually interact with that, right? I think that is going to be a seriously powerful part of this feature. That's where a lot of the fun's going to be had. But the caching system is pretty early stage right now, so by all means experiment with it, but I think it's going to have a fairly big overhaul at some point.
Continuing on that real quick, Jack, where do you actually set that? Where can you actually kick off like a cache? How do you actually do that? Not that we have to actually run through the process, but how do you actually, you have your set up, how do you actually start caching it?
Well, that was, as I say, that was this. One limitation I will point out is that the caches are currently picking up world-based transforms rather than local ones, right? So pretty much, if you want to play it back, you've got to play it back where you recorded it at the moment. But what we do is we would basically, this can be dynamic, it's behaving exactly the same, but down here we have cache mode. And initially we won't have anything in here, but we will the moment we tell it to record, okay? And then when we record, it's going to store that cache when we hit the end of the sim, and then we lay those caches that it's generated up into the level sequence and trigger that to play them back. You'll notice this quite peculiar one here called record and play, and that's basically, it's kind of like, okay, I've got a cache, I'm going to play my cache, and the idea behind that is, but I could still do things to that, right? And then I might want to rewind that playback at some point. I don't think rewind's up and running just yet, but the idea being, although you're playing the cache, record new information so that we can spin that back at some point, right? So that's what that is, and then play is kind of what you'd expect. But at the moment, I think there are some hiccups in the play command on just a geometry collection with a cache in it. Whereas, as I say, if you trigger that through a level sequence, which is what we did for the GDC presentation, that'll run super smooth. And you can also set things like you can set the play rate for that as well. You can reduce that, and it will play in nice slow motion and so on. So yeah, that's pretty much what caches are. Again, we'll be documenting a bit of that.
Yes,
to get people moving.
That was my own personal question there, because I hadn't done it yet, so yeah. I will be documenting that.
That's cool. We did have a question that was around. They actually asked that it seems like it's more for pre-written destruction and not emergent random situations, but the system is designed to work for both, right? Mm-hmm. And injunction. Yeah. So that's similar to the GDC demo. We have some pre-cached elements, sort of larger buildings and more several hundreds of rigid bodies that we wouldn't really be able to afford without caching them. But then you can also affect them at runtime as well. And so it is definitely.
Yeah, I mean, literally the last scene was a pre-cache one. That was a really early iteration of that tech as well. But the rest of it was all dynamic. Yeah. There's definitely an upfront cost, especially if you're using level sets for everything. In terms of building up all the connections and stuff. So obviously, the more complex things get, the longer it's going to take to spin up. But typically it's within an acceptable time frame, and I'm sure at a certain point there'll be ways for us to check against events and kind of consolidate when the game thread and the physics thread are ready. Stuff like I say, we're in beta. It's easy. It's all going to get sorted, but right now there are a few yeah, there are a few things that need ironing out.
I was pretty impressed with what we're able to do so far, and how far some of the paradigms have come that you can actually start learning them right now.
Yeah, I mean, also like it's come a long way in the time since we did GDC. I mean, really, like the tools that we were working with back then were real raw. You know, they really, really were. And what we've done is we've aimed to try and take what we had there and just sort of finesse that a little bit, clean that up, and get that so that we can get it out to everyone as soon as possible and get people used to these new paradigms of like fields and geometry collections and balancing all this stuff. So I guess like the main mission really for people like myself and Wes now is just to try and make sure that everyone gets all of the settings, what all those dials are doing, you know what I mean? And so yeah, very keen to be sort of feeding back and giving that information as much as possible.
Are you ready for a couple more questions?
Sure.
Okay.
Of course.
Will there be a more convenient way to clustering than using numeric indices? Is there a way to visualize what is clustered?
Fractured.
I showed how visual clusters work.
You should be able to see that in the Fracture editor. Yeah.
Right. Yeah, in the Fracture editor, you can do. Again, I mean, on that one, I'm gonna bounce back to the whole case of these are early stages. I mean, technically, it will be possible for us to do cluster. You could do a geometry collection that has no clustering, and you could potentially use a field to determine the strengths between the rigid bodies if you so wished. You know what I mean? You could do it that way too. I think the options for doing that at this stage are somewhat limited, but as it sort of evolves, I think we'll get a lot of that. But yeah, the clusters are broken up through the outliner, and as I was saying, if you just walk through them, you can see what they're going to be. I guess I seem to have saved something here. I was just going to use this one for illustrative purposes, but we'll worry about that later. But yeah, I mean, I guess maybe the question is potentially they might be asking, can we see the bone color for each rigid body at this stage? In kind of the same way that we see them all when we're in the all state, because the all state doesn't say the transforms of the clusters, because obviously it's showing everything on its own merits and on its own terms. So it might be something we could factor in to show what that spread is. That would be pretty cool, actually. It'd be nice if we had that toggle. So I'll bear that one in mind and push for that.
They were wondering, how do you make your ball bullet collide with your geocollision? In my project, my body and my bullet pass through. Okay,
so there's a couple of ways we can do things like that. Part of so the first thing I did with that ball bullet is this is a very chaos-centric solution I came up with on this one, and effectively what I'm doing is I'm spawning a field, and also a geometry collection. And I am using the collision of a geometry collection with fracturing on it. And when it fractures, at that point, I check for a break event. And at that break event, we just spawn a field like any other and cause an explosion. And so the ball can be spherical. However, it is also possible to apply things to static meshes as well. And we have this thing called static mesh simulation, again, somewhat in its infancy here. But you have a kind of a lightweight set of options that also the geometry collections have. In this case, obviously, I'm using a box collision. But it allows these things to respond to fields and geometry collections walloping against them as well. So that's potentially one option. So yeah, I guess hopefully that would answer the question.
So. Yeah, the answer is using, and so that static mesh simulation is an actor component, right, that you attach to the mesh?
Exactly, and then at that point you would choose the collision type and you would check sphere, and I guess give that a whirl, see if that works. I haven't had to do that personally myself, so but yeah, give that a whirl. Otherwise, you might try a geometry collection right now, or line trace, or something like that.
Let's see. I can migrate this easily to other projects, right? For example, I made a sim in a project, and then I'll migrate it to another, and that should just be using the normal migrate tool, right?
I believe so.
As long as you're heading up, yeah. Well, I did. So yeah,
Check.
we got an RTL branch that we had for SIGGRAPH, and yeah, we just migrated stuff out of this one over to that. No problem. Yeah.
That's awesome. Would it be wise to wait until the new full physics system is out to integrate chaos destruction into our game, or could we use physics and chaos in parallel?
I would wait until we say production ready, though.
Now that doesn't mean that you
You couldn't
can't,
use
you know, sort of make a little test game and sort of work with the tools to see what it's capable of right now and what you might be able to plan for the future.
Oh,
But
for sure. Yeah.
but sort of switching is not the state it is at right now. And so if you already have a project, then this is not the time to switch.
Right. Yeah, I'm pretty sure Mike would agree with that. As he say on the field, he probably have answered that.
No.
He might be over there. What do the colors on the level set collisions mean, if anything?
No, they are it's just a random spread. It's just really for visualization. As I say, if you use Shift B, you can toggle them off. I mean, every single one, this geometry collection here has no lower settings, but if I do Shift B, you can see if I switch between root and all, it just assigns a color just so you can see what's what. But Shift B, turn it off, and you'll just be dealing with specifically, what you're working with, which of course is very useful for something like, this, where I might actually be looking to see what's going on inside and checking how my textures that I've applied to those interior IDs are doing. So, being able to expand and then tune those to this model, that's an easy way of doing that. So yeah, at that point, bone colors would kind of get in my way.
Can you animate the culling field, for example, drag it along the player? Can it be a movable actor? I guess is what they're wondering.
That's an interesting one. I want to say you probably can, but I feel like Bryce will probably, reach his foot over from San Francisco and kick me. Try it is what I would say to that.
Yeah.
I don't think I've ever. Yeah, no, you can. Of course, you can.
It's just a component attached
we're
to
doing
the
it
actor,
in
the
the-
actor.
Yeah, we're doing it in this one. So this strain decay that climbs the building, it's got culling all around it. This is actually using a culling field to make it hemispherical. So because I'm only interested in this force riding upwards, and as the ball expands, I don't want to be catching stuff below. So this is being culled, and then the thing is just moving.
Climbing up.
And it could move super quick and release a whole bunch of stuff really, really fast, or it can, you control the, in this case, I would control the rate of rise and expansion on that. So yeah, it sounds like you can.
Awesome. Does Chaos use data-oriented design to optimize memory layouts?
Wow, you really fired that at the right guy.
Just trying to
Well, me reading them out loud will maybe make Michael or Bryce go ahead and give us some information here if possible.
Yeah,
It sounded like a smart question, so
Just keeping you on your toes.
it's a very
Jack,
smart
that's all.
question. It's definitely smarter than I am.
we'll leave that. And I was going to mention that the questions that Michael and Bryce already answered, I'm going to go ahead and post them on the announcement thread.
Sweet.
Since we're not asking them live, we got almost too many questions to be able to do that, so I want to go through the ones that haven't already been answered. But they'll be on the announcement thread once we're down here. Let's see. Does Chaos work with Sequencer? And the answer is yes, right?
Yep.
That's how we're caching the simulations.
Yep, exactly. Actually, and also, yes. No point expanding on that yet.
That answer is yes. Can you talk about how skeletal meshes come into play with this system?
I can't talk about it that much because I haven't done a lot.
This could be something
What I
to cover in
can
this
say
interesting
is
too.
there was a point where Jim
Jim was doing something.
my colleague on another senior artist dropped a house on a robot's head while it was moving, and to do that, he was using the skeletal mesh component, simulation component. I personally haven't had any experience doing that with this just yet, so I won't expand more than that. But there is a skeletal mesh simulation component that you could attach and play with, and you might get some success there. I'm not quite sure what state that's in at this point, but yeah, give it a whirl.
Yeah, it's good to know that it's coming. They were curious, can you show what the collision view looks like? I think they're curious to see what the collision view looks like with the collections. Yeah, just the view mode.
Yeah, I wouldn't think we're going to see an awful lot. Looks like we're picking up some bounds there.
And so the way
this is not typically how I would check collisions. In fact, actually, the collisions you're picking up there are actually invisible objects, which I'm using to stop this thing just, filling the entire hall with rubble. So yeah, you would use the debug draw thing that I showed earlier. It will show you boxes and spheres too. In fact, if we just real quick do that again, or really slowly do that again. There we go. Thank you. Yeah, so the debug draw actor here, if we show rigid body IDs, where are you? Where's it gone? So that's one. Oh, hide with collision. There we go. So what number's that guy up there right now? There we go. If I just turn them off. So yeah, there's its spherical collision, for example. If we had something with box on it, let's see if I can dig out an example of a box collision geometry collection. I'm sure I've got some. GC collision example box sounds quite promising. So let's, I'll actually make that static so it doesn't, I guess it doesn't matter, let's play. And yeah, there they all are, look. A whole bunch of numbers and boxes rolling around the floor. So,
nice.
So the analytic shapes are, showing up nice and clear. It's just level sets because they're, virtualized, that we have to kind of take a slightly different approach to showing what they're doing. Hopefully that answers that.
Mm-hmm. Yeah, I definitely think it does.
Yep.
And you can also look at it in the when you're actually fracturing as well, right? Because that's how you will visualize each chunk. If you want to see what they look like, stepping back and forth like.
But you do need to run the debug draw. Oh, actually, yeah. I wonder if that's just for level sets though. The debug draw actor. Typically, I run it during sim time. During play rather than while I'm in the editor. That said, I don't know if it's possible. It might be possible to drag one into the scene and maybe visualize some of it outside of play. I'm not 100% sure on that, but I think it does require play to do. Yeah.
Okay. I think we had a question here. I just want to reiterate on. Someone probably came in late, but they were wondering if chaos is all procedural destruction, and or if I can prioritize certain areas of a mesh. For example, have a place or one piece of it stay stable or following a certain axis. And I just wanted to reiterate that we went over that in the second part of Jack's demonstration, and so you can go back and view that using anchor fields.
Yeah, that's the key to putting up big buildings. So definitely go back and watch how we did that. Again, there are going to be examples of all these fields and a lot more inside of the content examples. So feel free to just migrate those out and play with those and modify them and come up with your own, interesting combinations. There's going to be a lot. So guaranteed we haven't hit all of them.
All right, and then I wanted to briefly touch, because we had a couple of questions regarding multiplayer, which is common, because of course we want to get together and destroy things.
Right.
And there were a couple of questions around it, so I think we can just touch on it a little bit, and that is that currently there is no sort of special system to either optimize or make sort of server authoritative physics working in chaos. Is that correct?
This sounds like it would be a good technical physics chaos destruction stream, I think, because it's still in its infancy. Like I haven't done anything with
it's
network physics yet.
I mean, like I say, right right now it's I guess the sort of more fundamental things are happening. I don't think it requires sort of special support at this particular point. That's not to say it won't be. Like I say, Chaos is going to be the physics system of Unreal's future. So that stuff's going to get solved, and they will talk about it when they're ready to talk about it, when it's in a position where people, should really be looking at that. Right now, what we have is, we're just introducing this stuff to the user base and getting feedback on that so that we can develop that aspect of it. But it's coming. It's coming.
And then I think we'll do a final question here, which is, what do you think is the game changer with Chaos Destruction? Maybe not now, but the vision of Chaos for dynamic artists for game dev.
The game, right? So I've been working with Unreal's destruction stuff for a while, and the thing for me that is fundamentally cool about what Fields bring into play is just the amount of control we have over when things do what they do. We can be very, very explicit about how things decide to break when they decide to break. We can, using Fields, we can force the issue whenever we like. So if I'm a designer and I'm saying I definitely need that thing to fall down right now, I can do that. If I'm a designer and I say I really need to know when that's going to fall down so I can trigger something, we can tell it that. All of these things are just that's really, really cool. And I think the other thing is the potential of the kinematic cached state stuff is just awesome. The idea that I can simulate something which would take an absolute monster computer to run in real time, and I can pre-cache that, and then I can say, I want it to feel like this thing's still dynamic. I want to hold up my shield and see the pieces bouncing off of it, right? And just those pieces will. You know what I mean? Everything else is just running on its little pre-authored track. But as a user, as a game player, I'm not going to notice the difference. It's all going to feel like, you know what I mean? Those sorts of levels of control, I think, are going to be massively cool and a big, big game changer. The simulations that we're getting now are pretty early stage. There's a whole bunch of other cool stuff that's going to feed into how those things start to collapse, the shape that they take when those masses start to break. This is just iteration 1. This is just beta. We've got more to do, and it's coming.
That's good. It's exciting. Thank you, Wes and Jack, for taking your time out of your day to come here and talk to us all about.
It's a pleasure.
Yeah, and I think we'll have you both back at some point. Probably around the same subject. Yeah. Well, maybe not fundamentals, but maybe we'll go in a little bit more in depth.
Do some gameplay stuff.
Yeah, that's what I was thinking.
I think we should get Jim and I back later to do a bit of sort of some of the advanced fracturing type stuff and some of the advanced field stuff, and we can kind of pick up from this. I'm hoping that we're going to start seeing some really cool examples coming in where we kind of see, some other things that we didn't even think of. We're experimenting at the moment and coming up with all kinds of quite fun stuff. But we've just scratched the surface at this stage. So definitely, watch this space, and we'll be back for more at some point, maybe later in the year.
That's great. And I'd like to take this opportunity to mention that we have been, we do captions for the live streams, and this we get a transcript out of that, and we have started posting that in the YouTube description for the videos. And what that means is that if you're looking for a particular part of the live stream, you can actually go ahead and open up the transcript and search for key terms, sort of like, physics or chaos or material or what it would be. And so that's a really good way because we know that, during this hour and 45 minutes that we've been here talking about this, there's quite a bit of information to digest. And so a good way to be able to go back and figure out where we mentioned things or maybe where we asked your question, you can use the transcript to search for that, which I think is really neat. It usually goes up a couple of days after the live stream is up, because we actually need to caption the entire the entire stream first, but I want to go ahead and mention that. And then let us know what you thought of the stream. We have a survey link that I think Amanda will be pasting in chat. Go ahead and let us know what we did well, how it went, if you like the topic, and then make sure that you go ahead and fill out what you would like to see on the stream. It's a good way for us to know what you would like to see in the future. We got a lot planned, but there's a lot of future. And if you go ahead and enter
really hoping we covered all those fundamental things. I think we did, but there may be a few holes. It's possible. So yeah, definitely hit us up with some of those.
Yeah, well, like we mentioned earlier, and it's worth to mention again, is that the examples will be available for download when
Project,
423
along
comes
with the
out.
documentation and this Twitch stream. So
Yep.
a whole bunch of information for you guys to digest and kind of experiment.
It's great. And then, as always, if you have meetups and user groups in your area, go ahead and go do them. It's a great place where you can, bring your projects and talk to other developers about what you're doing in your area, get a little sense of the community other than just online. You can go ahead and go to unrealengine.com/user-groups, and you can see where they are in the world. If you don't have one in your town or anywhere nearby, you can go ahead and contact us if you would be interested in organizing one, and we'll make sure to help you out with what that involves. And some of our other online communities, we got our forums, the Discord, we have a good Facebook group, and the Discord is an unofficial Slack, it used to be a Slack channel. It is now a Discord server called Unreal Slackers, where everyone is helping out now. I think we're about to hit the 26,000 member mark, which is really amazing. So thanks to our community members that are running that. They're doing a great job. And then if you'd like for us to spotlight your game at your game or your project, it could be either or, could be something that involves Unreal Engine that isn't necessarily a game as well, make sure that you'll let us know about that. On the forums we have a thread, work in progress as well as releases. Just go ahead and post and let us know what you're doing there, and then we might be able to go ahead and show the world what you're working on. And if you've seen the countdown video that we have at the start of the stream, that is a 30-minute recorded segment of you working in your project. Go ahead and fast forward that up to 5 minutes and send that to us with your logo to community@unrealengine.com, and we'll be able to show a nice little countdown of what you're working on. And as always, if you're streaming on Twitch, make sure that you use the Unreal Engine tag so that we can join you and see what's going on and say hi. And as always, follow us on social media, and special thanks to Wes and Jack for taking time out of their day. And I believe we will see you all next week when we are doing Unreal Insights with some of the people from our team in Sweden, which would be great. So until then, we'll say thanks, and we'll see you next week.
Thank you.